So this is part 2 of the Unit 6 lectures, where we're going to look at a much larger case study. Basically it puts together everything that we've learned in all the previous lectures and puts it together into a large program in the form of a game that we talked about like last time. Wilf the Window Smasher. And what we're going to do is build this program up in stages, a little bit like a lot of you did on the assignment, where we built it up as stage 1 through to stage 4. And what we're going to do is we're going to look at each stage as it's built up, and then we're going to test it before we talk about the next stage. So we'll start off in the beginning bit just by reminding ourselves of the spec of the game. So we've got 2 characters involved in this game. We've got Wilf the Window Smasher, who's represented by the computer, and the Caretaker, which is played by you, the user. And the scoring system revolves around Wilf, who basically scores points by smashing windows and sneaking away, and the Caretaker, played by you, attempt to catch him before he reaches a maximum win point level. If you remember from last time, the grid is based on XY coordinates, so it's 2-dimensional, and the location of the windows in this particular building are at the intersection of all the coordinates where the value of X and the value of Y are even numbers. So if you remember from last time, 2, 2, 8, 6, 10, 10, 4, 10 are all positions where both X and Y are even numbers, and that's quite important when we detect the position of Wilf as he moves around the board. And what happens is that the Window Smasher starts at a random position, random value from X is 1 to 10, and a random position of 1 to 10 for Y. But we also have a random initial direction as well, and I did talk about this a little bit in the last lecture, so I'll not repeat myself too much. But basically we've got an initial direction which is based on the generation of 2 random numbers. Both of these random numbers will either be -1, 0 or +1 in order to indicate the initial direction. So the extremes that we can have are the movement in X, which is based around the movement across the top. So that's our value of X. And then we've got the value of Y, which runs top to bottom. So if, for example, we draw 2 random numbers and the value of X is equal to, let's say, 1, and the value of Y is equal to -1, what it means is the value of X is moving in a positive direction from left to right, in which case we're dealing with a movement in this particular direction from left to right. Okay, so we're moving either with that one, or that one. When we're dealing with the Y coordinate -1, what we're doing is we're dealing with a movement which goes from 1 through to 10 from top to bottom. So if we was positive, we'd be going 1, 2, 3, 4 all the way up to 10, but we're not. We're actually moving in a position or a direction which goes in this direction, in which case the value of 1 positive, moving that way from left to right, and -1, which is moving up. So we're actually dealing with this direction. So our value of X1, Y -1 means it will be moving initially in that direction. So in the first phase, what we're going to do is just put some of the functionality in there. So we're going to put the window cleaner at a random position on the grid. We're going to set the random direction up, and we're going to create the initial class in order to perform that functionality. But before we have a go at that, based on what we know so far on this slide, what instance variables do you think we need, and what methods do you think we need? And what I need you to do, and it's another one of these again, it's your opportunity to pause the video for 5 minutes, just take a look at the content of that slide and think about what sort of information we would need in order to store those. So again, it's instance variables and methods. Pause the video, 5 minutes, and then we can come back again. Okay, so here's our initial class diagram, and we've called it Window Smasher A, okay, because it's the first version of it. In terms of instance variables, we've got xpos and ypos. So we'll use xpos and ypos to set up the initial x and y position on the grid. For the work that we did last time on generating random numbers, we need a random number generating object. So I've actually used exactly the same name as the one that we've used before. And we also need a move method, and that will be the one that allows us to move one square in any random direction. So what we'll do is we'll have a quick look at that program and see how that affects things so far. So I've opened Window Smasher A, I've downloaded it from the VLE and I've opened it up. So what we'll do is initially we'll get hold of the source code and we'll just try and evaluate it and see what's going on. So what we've done, or what I've done, is just take the values from the UML, the instance variables and the methods, and I've put these into a very small program. So what we're going to do is have a very quick look and then run it very quickly just to see how things are getting on. So what we've got in the initial situation here is we've got our class, which is called Window Smasher A, and at the top, because we need to use random numbers, we have to import that functionality from java.util.random, and that will give us the functionality to generate random numbers in our program. In the instance variables, I've declared two integers, one for x position, one for y position, and I need to create an instance of a random number generator. So I've declared an instance of random and I've called it mrandgen. So they're the instance variables that we're going to use. In the constructor, I've sort of finished off the random number generator by putting an instance creator inside the constructor. So mrandgen will be a new instance of the random number generator, and that means we can call on its functionality in the program to create random numbers. In fact, what we've done is we've actually used that almost straight away in the constructor, because we've set the initial position of x and y by using our random number generator, which we've actually used there. And we can see we've got one there and we're using the same one there. And what we're doing is we're setting the x position to a next integer from a value of 10. Now, because our grid runs from 1 to 10, the initial random number generator actually runs or generates numbers from 0 to 9. So what we have to do is generate an integer from 0 to 9, and in order to map it to a value between 1 and 10, we have to add 1 onto it. So as an example, if the x position, this command generated 0, we don't have 0 on our game board. It runs from 1 to 10. So we have to generate the random number, which could potentially be 0, add 1 to it, which will give us a position of 1. And the opposite of that could be when we generate our y position, which would again possibly generate a number between 0 and 9. We might get 9, but we'll never generate 10. So what we have to do, if we generate 9, to make it fit into the 0 to 10, we would have to add 1 onto it. Any number in between, so 6 would generate 7, 2 would generate 3, but that would allow us to generate numbers in the range of 1 through 10. So we've set up the initial position. What we've done in move, which is the only method that we've got at the minute, is something very similar. We've used a position in order to generate the position on the game board, but what we have to do as well is set the initial movement. Now remember, when we do the initial movement or direction, that's done based on a random number that's generated between -1 and +1. It can only be -1, 0 or +1. Now in order to generate numbers in that range, what we have to do is generate an integer from 0 to 2, hence 3, and then take one away from it. So if you think about how that works, if I generated, and I'll type it on here, if I generated 0, 0 minus 1 would be -1. If I generated 1, then 1 minus 1 would be 0. And if I generated 2, then 2 minus 1 would be 1. So what we've actually done is, through the use of this line of code, if we generate a 0, that generates the -1. If we generate a 1, that generates the 0. And if we generate a 2, that generates the 1. So they're the initial directions that we're actually looking for in the right range. And we do that for both the X direction and the Y direction that we need for this particular program. So let's give it a quick compile and let's create an instance and inspect it. So as you can see, the constructor has already generated a position of 2, 1. So what we do is we generate those two positions. This is an example of the random number generator, hence the strange symbol. Don't worry about that, we're going to come across that in some other future lectures. But if I generate a call move, we've actually added the values of 0, -1 or +1 onto the initial direction. Alright, so again, if I call move, the random numbers have been generated and added on to the X and Y positions. So every time we call move, the X and Y position will alter accordingly. And it's completely, well, I say completely random, it's based on the generation of random numbers. Okay, so let's carry on with the rules of the game. So, every time our main game character moves around on the grid, he's got a 1 in 4 or 25% chance of changing into another direction. If that happens, he will always move one space in that current direction, and we've already seen that in that line of code in the move method, where we change the X and Y position according to a random number between -1 and +1. If our window smasher hits any of the sides of the grid, we say that he bounces, which basically means that he stays at that boundary, but the direction is reversed. So if he's moving in a -1 direction, X or Y, he moves in a plus direction. If he's moving in a 1 direction, he moves to -1. If he's -1 to +1. When the window smasher bounces, that will reveal where he is on the game board, whether it's top, bottom, left and right, and that will give us a clue for us, the game player, to make a guess somewhere around there. So in phase 2, what we need to do is basically set the game board up and then add some other aspects to it in order to fit those in. So we need some constant variables for the size of the grid. which we know is 10 by 10. In the constructor, we're going to set up the initial direction as well as the start position, so we need to add a little bit more to the constructor, and then we're going to have some new instance variables to store the current direction that the window smasher is moving in. We'll have to change the move method to decide whether we're going to change direction or not, so that's where our 1 in 4 comes into play, and that'll need some explaining. And we need to put some tests in to see if the window smasher has reached a boundary, and if we've reached a boundary, we'll need a message to tell us that a bounce has taken place. So we need some changes to our class diagram. The original elements like move are still there. We still need X and Y position, and we still need our random number generator. But now what we do is we need to store our X and Y direction ready to move our character. So this thing about percentage chance of changing direction, okay, what we do is we use a random number generator, and we do this to generate a random number between 0 and 1, so it's going to be a fractional number. If we generate a random fractional number and it's less than 0.25, now anyone who's done maths know that 0.25 is a quarter or 1 in 4. So we're actually generating a random number and testing to see if it's below 0.25 or a quarter. If it is less than that, then we can change direction. And what we're going to do is we're going to store that 0.25 as a constant called direction change chance. What that means as a programmer is that if we want to make the game harder in the future, we can actually modify that number and make it, for example, 75%. So there's a 75% chance they're going to change direction, which might mean it'd be very difficult to detect what direction the window smasher is moving in. So here's an example of the code that we're going to use. We're going to use a double, which is a variable with fractional parts, and it's called rand change. And what we're going to do is use part of the random number generation engine called next float, not next int, because we need to generate something with fractional parts. Our direction change chance constant, which we know is going to be 0.25, we put in an if statement. And if the number that we've just randomly generated, rand change, if that is less than 0.25, then what we'll do is we will regenerate the X and Y direction that the window smasher is going to move in, using the same code for generating a number between -1 to +1. And then we will put a message on, basically giving at least some clue to the player that the smasher has changed direction. We also need to incorporate a test on bouncing. So if we reach the left hand side, then we have to change to the opposite direction. So let's just take one example and think about the window smasher moving left. So if the window smasher is actually moving left, okay, remembering the initial grid that we set up, so again poorly drawn, but we've got X and we've got Y. If we're moving left, the current X direction will be in this direction, in which case it's -1, because everything goes from 1 to 10 moving left to right. We're moving opposite to that, so the value of X will always be going down by 1. If we're moving straight, then the Y direction will be 0, because we're not moving sort of in an angle, we're actually moving straight. So that means that the Y direction, which is up and down, doesn't alter, in which case that will be 0. So X direction is -1, Y direction is 0, So the X position will change by -1. We're moving left. The test will be when we hit this edge. And when we hit this edge here, the value of the X position potentially will move from X equals, for example, 3 to 2 to 1 to 0. So if the X position becomes less than 1, i.e. 0, we've hit the left hand side, that could potentially take us outside of the grid. So what we do is we change the direction that we move to +1, so that means that we now move in that direction. That means the X position is set to 1, which is an indicator that we've reached the left boundary. On the right hand side, it's a very similar situation. If we're moving right, and again, let's have a look at this while we're drawing it. I'll move the boundary like this. We've got X, which moves from 1 to 10, and we've got the Y, which moves from 1 to 10. But what we're doing this time is we're moving right. So if we're moving right, the current X direction will be 1. So our character is here, we're moving that way, and the X direction will be 1. So 8, 7, 6, 5, tell a lie, 6, 7, 8, 9, 10. The Y direction will be 0 because we're not moving diagonally. So what will happen in this case is that the Y direction will be 0. We're not moving up and down, we're just moving straight across. So the X position increases by +1. And then what we need to do, if we're going to detect we're hitting the sides, is we have to detect that the X position becomes greater than the maximum that we're setting for the grid. And the maximum that we're setting for the grid in this case is the constant grid X max, which is 10. Again, what will happen is when we hit grid X max, or when we get bigger than 10, we set the direction to move in the opposite direction, which means we make it -1. Okay, in the slide the minus is there and the 1 is there. Don't get confused by that. We then set the X position to 10, so we keep our character at position 10, but the direction will always be now in the minus because we've bounced and we're moving the other way. So let's have a little look at the left and right code. What we do is we change the X position by the current X direction. Now that could be -1 if we're moving left, or +1 if we're moving right. This code at the top, this if statement, tests for the X position being less than 1. Well, the X position being less than 1 would mean we're actually testing for the left hand side as opposed to the right hand side. So if the X position becomes less than 1, i.e. we've moved beyond the left hand side of the game board, we set the X position equal to 1 to keep them there. We set the direction to +1 to move them in that direction because we've bounced, and tell the player that they've bounced on the left hand side. Let's change colour. Let's change it to green, and then we'll do the test for the right. So if the X position moving this way becomes greater than grid X max, which is 10, because we're testing for the right hand side. So again, we're testing to see if we're moving X +1 is greater than 10. Set it to 10 to keep them on that right hand side, but set the direction to -1 so that we bounce off that side. And again, tell the user that the smasher has bounced on the right hand side. So have a bit of a think. We've gone through quite a lot, so you might have to go back and re-look at those sections again. But what I want you to do is have a think about bouncing off the top and the bottom. Now, bouncing off the top and bottom won't have an effect on X direction. It'll have an effect on Y direction. Y direction moving up and down, and Y position moving up and down. Remembering that the top boundary is at 1 and the bottom boundary is at grid Y max being 10 as well, and have a go based on what you've seen before to try and move up or down and bouncing from the top or bottom. It might take you a bit of a while, but have a think about it, get away from the video and try and sit down and try and work it out for yourself. Base that on the work that you've just seen for bouncing on left and right. And what we'll do is we'll have a look at that in the example for Window Smasher B. Okay, so I've downloaded the Window Smasher B application from the VLE. We'll give it a quick compile just to make sure everything's alright with it, and it should be. So let's have a look at the code that's been written behind it. A lot of it is very similar to what we've seen before. All we need to do is just look at some of the changes that we've talked about in the previous slides. So Window Smasher B still needs to use the random number generator, so you need to bear that in mind. We've set some constants for the size of the playing area called grid X max and grid Y max, and later on you could potentially make this a much more difficult game by setting those numbers to something bigger. Likewise, you could make it a lot easier and make them a lot smaller as well. We've also set a constant, which is a double, which is the percentage chance of changing direction, and we've set that to 0.25 or 1 in 4. Again, you can modify that in the future, make it easier or more difficult. Smasher position, 2 integers for X pos and Y pos, and our direction, which we set as current X direction and current Y direction. And of course we need our random number generator as well, because we use that in order to generate all random numbers, whether they're integers or fractional. In our constructor, we create our random number generator and we set up the initial position much the same as last time. So that's a random number from 0 to 9 for our 10 and add 1 to it. And again for the Y position, again a number from 0 to 9 and add 1 to it. We also set up the initial direction, which will be a number from 0 to 2, and we take 1 away, so that's the 0, -1, 0, +1, and that's exactly the same for the Y direction as well. In the move method now, we've got all the code for bouncing off the sides and for changing direction, and we put lots of user.message elements in there to test for that. There's also plenty of comments, and you can download and read those to make sure you understand them. So this has all been written in one move method. So we'll start off with the chance of changing direction. So what we've said is let rand change. Now that's a double or a fractional number that we've set up, and that will decide whether we need to change direction. So we generate a floating point number. By calling it like this, it will actually automatically generate a number between 0 and 1, which is obviously a fractional number. If that number is less than the direction change chance, which we set as 0.25 up here, if it's less than 0.25, we generate 2 random numbers for X direction and Y direction, which will either be -1, 0 or +1. And we tell the user that they've changed direction. So again, that technically would only happen 1 in 4 times. Then we use that, whether it's changed or whether it's not changed, it may have changed, 1 in 4 chance that it may have. And then what we do is we modify the position based on the current X direction. So we set the X position equal to the X position plus the current X direction. We add maybe -1 to make it move left, +1 to make it move right, or 0 to make it not move at all. We then test for bounce left and bounce right. So if the X position becomes less than 1, if we're on the left hand side, which is 1, we move -1, which would take it to 0, then we have to keep them left, bounce on the left, so we change direction, so we go from -1 to +1, and tell the user they've bounced on the left hand side. On the other hand, if the X position becomes greater than the size of the grid, which is 10, so if the X position becomes 11, because we moved right +1 to 11, we keep them at 10, we set the direction to -1, that means we've got them moving left because we've bounced and we're moving in the opposite way, and we tell them that they're moving right. In this section, we deal with the movement up and down. Works in a similar way, and you should have had a go at this. So, in terms of moving up and down, we set the Y position equal to the Y position plus the Y direction. If the Y direction is -1, we're moving up. If the Y direction is moving down, it's going up. I'll start that again. If Y is moving up, we're moving down. The number is going up. If the Y position is moving negatively, we're moving up the board. And if Y position is 0, then we're not moving at all. If the Y position becomes less than 1, so that means at the top. If it becomes less than 1, i.e. it's at 0, then they're at the top of the board. So we keep them at the top, change the direction to positive, moving down, and tell them that they're bouncing at the top. If the Y position becomes greater than the maximum size of the grid, which is 10, which is at the bottom, we keep them at the bottom, change the direction to -1, which means that they're moving up, and we tell the player that they've bounced at the bottom. So, in a rather long and convoluted way, we'll compile that and create an instance, and we'll inspect, and let's have a look at what's exactly going on. We've got the two constants for the X and Y size of the board. We've got an initial position of 4, 8, which is sort of about halfway along and about almost to the bottom, and there's a 25% chance that they're going to change direction. Our initial X and Y direction is 1, 0, so X is +1, that means it's moving right, and the Y direction means they're not moving up or down. Okay, so if I was to call move, what's happened? Well, at the minute, we've generated a chance that they've changed direction. So this actually is generated a number less than 0.25. So the smash has changed direction, and the X and Y direction has altered to 0, 0 this time, in which case they've not moved. They actually stay at 4, 8. It's rare that that happens. If we move again, we've got no change at all because they've not moved. Let's try that again. It doesn't look like they've moved again. So it doesn't look like they're moving at all. But initially, we can actually see that when we generate these random numbers, it has an effect on the XY position. Okay, so the next phase means that we have to now start implementing the third set of rules, and this is the turn-based stuff. So let's remind ourselves again of the rules in terms of the movement. Window Smasher always starts, and the way it works is that he moves again, then checks that position to see if there's a window there. Now remember, windows are only available in areas where the X and Y location are even numbers, so it's important to remember that. If there's a window there, they get 5 points, and then they go back to step 2, so they can move again and check to see if the window's there. So potentially they could keep going and smashing loads of windows. When a window gets smashed, it reveals the XY location to the caretaker to give you at least an indication of where they might be. But if they do a move and there's no window there, they're allowed to move once more and the turn finishes. If you're the caretaker, after all that moving and smashing's taken place, you're allowed to input the XY position of where you think the window smasher is. If you're near enough, you catch them and you win. If you're not, the window smasher might get another 10 points for sneaking past. Now, we're going to concentrate first on the window smasher. Alright, we've done the move method. We can call that whenever we want. But we now need to have a bit of a check to see if the window smasher is actually landed on a window location. And if so, we tell the user that a window's been smashed and we can update the score. So what we're going to do is we're going to add a method called check window. So every time we make a move, we check to see if the window smasher is landed on a square. So what we need to do is do that, as well as add some instance variables for score, and we're going to set the target score as well. That'll quit the game if the window smasher reaches that target score, like 20 or 30 or something like that. We're also going to add a constant called smash score, which will allow us to set the points awarded for smashing a window, which currently we'll set at 5. Now, as I mentioned before, windows are located at every even row and column, 2, 2, 4, 4, 8, 6, and so on. If you divide the position of a window by 2 and the remainders are 0, then it must mean that we have a window in that location. If we think about that, if you've got window of a potential window location at x2 y4, if we divide the x location by 2, so 2 divided by 2 is 1, remainder 0. If we divide the y location by 2, now 4 divided by 2 is 2, remainder 0. In which case we know that there's a window location, because when we divide the x location of the window smasher by 2 and the y location of the window smasher by 2, and they both come out with 0 remainder, we know that they're at the location of a window. Now, in order to obtain the remainder, we did look at something called the mod operator. We did it way back at the calculating section. If it's a case of the remainder of the division of the two locations gives a 0, then we know we can smash the window and increase the window smasher's score by 5. We could do that so that check window returns a true if a window is smashed and false if it's not been smashed. So that's the scoring system for the window smasher. And then we can have a look at, for example, this picture that we've seen before, whereby when the caretaker tries to catch at a particular position, its outcome depends on how close we are. And we said if we're within the red zone or within 1.5 units, we've caught the window smasher. If we're in the blue zone or the 2.5 units, he sneaks away and the window smasher gets 10 units. Anything outside 2.5 units makes no change whatsoever. So the way that we do that is we're going to use a new method called try catch. And what we'll do is we're going to type in the two potential positions of where we think the window smasher is. So we're going to have an X guess and a Y guess. And what we have to do is work out the distance between the actual position of the window smasher and the our own position. And we're actually going to use Pythagoras theorem to do it. Probably the only time you've ever used Pythagoras theorem outside of a maths classroom. But what we're going to do, we're going to use it in order to calculate the distance between 2 points. If you've not done Pythagoras theorem for a while, it's reasonably straightforward. It's all based on right angle triangles. So, the old sum of the square of the two sides, like that. So, we've got a right angle triangle. Let's say this is where the window smasher is. Let's say this is where the caretaker is. And what happens is, when we're working this out, is the window smasher will have an X and Y location, and the caretaker will have an X and Y location, drawn badly. We can use Pythagoras theorem using these XY coordinates in order to determine that length there. If that length is very small, i.e. less than 2.5 units, then we've caught the window smasher. If it's over the 2.5 units, then they've escaped. So we can actually use our Pythagoras theorem theory in order to work out the distance between us and the window smasher and determine whether they've been caught, whether they've sneaked away, or if we're nowhere near. We also need to think about some other bits and bobs as well. So we need our winning score, and we need to test against that to see if we've won or whether we've actually lost, because if the window smasher reaches the target score, we've lost straight away. We're also going to use a Boolean variable called mCaught, which will tell us when the window smasher has been caught, which will give us an indication that if it's true, we win. Both of those are going to be passed as parameters to the constructor, and we'll have a look at that when we look at the next example, which we're going to do right now in the form of window smasher C. Right, so I've downloaded Window Smasher C from the VLE, and what we'll do is we'll spend a few minutes just examining what we've talked about and how it's implemented in Java. So what we're going to do is open up the editor, and we will just examine the code that's been generated. Okay. So a lot of it is more or less the same, so all I'm going to do is just highlight the changes rather than repeat myself. So things like constants for the size of the grid, the same. Probability of change in direction declaration, the same. Two more constants. The constant for window smasher's score when he breaks a window set to 5, and constant for escaping past the caretaker, 10 points. We've got the X and Y position of the smasher, the same. The direction that they move, the same. We've got current score, which we're going to use to basically keep track of the current score of the window smasher, and the winning score. We've also got a Boolean, which we've set up for whether they've been caught or not, and the random number generator that we've used since version A. So, where are the differences in the constructor? Well, the first thing we do is we have a parameter set for the constructor, which basically means that we have to set up the winning score for the window smasher to get in order to end the game. So when you'll see that when we run it for the first time through, it'll ask me for a winning score, and I'll set that about 20 when we do that in a bit. The random number generator is the same. The X and Y initial position is the same. The X and Y direction is the same. But what we do is we have to initialize the window smasher's current score to 0, and we use the winning score which we set from the parameter to the constructor, and that is assigned to the variable M win score. We also set caught to false because obviously at the beginning of the game the window smasher hasn't been caught. So let's have a look at some of the methods. The 25% change direction rule hasn't altered. The detection for the X coordinate left and right bounce hasn't altered, and the detection for the top and bottom coordinate bounce using Y, that hasn't altered either. What we have got now is some new code, so we're going to look at each of these individually. So the first thing we've got is try catch. Okay, try catch is a little bit different in that we've got two particular new areas. First one, this particular method has got two parameters, an X position and a Y position, both integers, called pinspect xpos, pinspect ypos, and we will be asking for those in order to work this particular method. So they will be the guesses, and what will happen is that based on the result of what goes on in here, we will return a boolean. That boolean will be true if we've got them and false if we haven't caught them. So the first thing we do is we, as it says in the comment, we calculate the distance between the smasher and the caretaker, and we do that by using another method called distance. Now distance is actually down here. I don't want to dwell on this too much, but if you go back to your old maths books and think about Pythagoras, so a squared equals x squared plus y squared, and the square root and the powers and things like that. I'm not going to go into the maths into that too much, but that's basically the two values that have been passed in from the X inspect position and the Y inspect position. We pass those into there. It uses Pythagoras theorem, which is this, to work out the distance, and it returns that distance back, and that's about as much as you need to understand of that, and it's stored in a variable called proximity. Once we've found that value out, if it's less than 1.5, that's an easy one. If it's less than 1.5, they're in the red zone, if you remember, and basically we can say you've got him, and we can return true with that boolean. Otherwise, if it's less than 2.5, then they've sneaked, in which case we can add the escape score, which is 10, to our window smasher's score. We can say that he's sneaked past you and 10 has been added on, and we just show the score to the user, and we return false because the result of the try and catch is basically not worked. Anything over 2.5 we say nowhere near, and we return false again from that boolean. We've already looked at the distance calculation, so let's have a look at check window. Remember, we use that modulus for dividing the X and Y position by 2 to see if there's a remainder. So we divide, in this check window, we divide the X position by 2 and put the remainder in X mod 2. We divide the Y position by 2 and put the remainder in Y mod 2. And we say if X mod 2 is 0 and Y mod 2 is 0, then we know that a window has been reached. So we add the score, a smashing score of 5 to our window smasher's current score, tell them that the window was smashed at X position, Y position, and we update the score and tell the user. If we check the window and there was a fractional remainder which wasn't 0, then there was no window there. We can just return false with this boolean and say no window was found. So based on that, we can compile it and we can have a go. So first thing it does in the constructor is it asks for a winning score. So let's keep it nice and low to start off with, and we'll set it to 10. Might regret that. And let's inspect, and we've got quite a lot of information in this list now. Some of the things that we need to bring to your attention: we're currently at 2.7, moving x minus 1, which is moving left, and current direction y is 0, so it's moving left in a straight line, and we've initialized the winning score at 10. We've not caught them, so we can carry on from there. Technically we're cheating by looking at the data, but let's see how we go on. First thing we'll do is we'll move, and we've performed a move, and we've sort of hopefully changed the x and y position in there. When we move, we then have to try and catch. So we're asking for two variables at this point, so let's ignore what's going on in there, and let's say 5 and 5, and it tells us that we're absolutely nowhere near. Okay, now what happens is that that will return false back to the program. So obviously we can then perform another move, and this time it tells us that it bounces on the left hand side, and we can check that because he's at x1, which is the left, and y7. So in that case then what we'll do is we'll try and catch him, and let's do it at 2.7. Let's say we're having a good guess. Straight away it tells us that we've got him. So the conditions that we're putting in to attempt the guesses, we know that they're actually working. And again, it returns that true because we're actually within 1.5 units of distance between ourselves and the window smasher through Pythagoras theorem. So we've more or less got the game put together, but you probably noticed that I had to manually call the methods, which isn't a very good way of playing the game. What we could do with doing is basically automating it, simulating the turns, and then inspecting the instance variables so that we can see the results as they get done. So what we're going to do is we're going to add one more method called play around, and what it'll do is it will automate the whole process of actually running the methods that we need to play the game. So moving the window smasher according to the game rules, breaking windows where he finds one, asking the user to enter the position of the caretaker, and updating the scores. And if it does that in an automated fashion, all we'll need to worry about is typing data in. We'll let the game actually do the actual hard work. So we're going to use a special method to do it. We haven't covered this before. Now, if you've been looking at any other third-party material on Java, you might know that there's a method flying around called main. I've avoided it up to this point, but now we've got an ability to use it proper, and we can use it to do more than just automate processes. We can actually use it to create objects and call methods. So when we usually create an instance of an object, we right click it, and when we right click it we say new window cleaner or new car park or new hotel. But what we're going to do is we're going to have the option to run main, which will do a lot of the automation for us, or we can create a window smasher object by right clicking it. It actually isn't going to make any difference. So we're going to use main to code the final set of rules, and then in the final game I'm not going to worry about this too much because it's sort of additional for what we're going to learn, and you're not going to need this certainly for assignment 2. The special effects with the wave files, I'm not going to concentrate on that too much, but like I say, if you want to have a look at that yourself, then by all means you can pull the final version apart and see how that works, but I don't want to worry about it too much. In terms of the main method, the Window Smasher and the Caretaker take alternate turns until either we catch the Window Smasher and we win, or we reach a specified number of points, like 40 or 20, in which case the Window Smasher wins. So the main method that we're going to create creates an object of Window Smasher without having to right click, which is a strange one, and we're going to pass the points target as a parameter. We're then going to use a loop to call play around and keep playing until the game is actually over. Either we win or the Window Smasher wins. And then what we're going to do is, in your own time, you can then sort of play the game and modify some of the points targets so that you can make the game actually easier or harder depending on what it is you want to do. So we'll have a look at the full game and we'll show you some of the automated elements, and then obviously you can spend some time playing around, actually having a look at making some changes, making the game harder or making the game easier, which is up to you. Right, so this is the final version of the Window Smasher game. This is the fully fledged one, and what we'll do is download it from the VLE. It's just called Window Smasher. It's not A, B or C, they're the build-up exercises. So what we're going to do is we're going to open it up in the editor, and we'll just examine again some of the new bits and see if we can get our head around those. There are a lot of elements in there which still exist from the early ones, and again I'm not going to concentrate on those too much. I just want to concentrate on new content. So again, random number library is the same. The X and Y grid max values for the size of the grid are the same. The percentage chance of changing direction is the same. The smashing score and the escaping score, those two constants are the same as well. The instance variables for X and Y position are the same. The X and Y direction of movement is the same. The score and winning score setting are the same, and the Boolean to detect whether they've been caught yet is the same, as well as our instance of our random number generator linked in to the library import at the top. In our constructor, that's all the same. The random number generator, the random number for initial position on the grid, the random number for the initial direction that they move. Initializing the score to 0, using the parameter to the constructor to set the winning score for the Window Smasher, and the initial value of caught being set to false. Our move method is exactly the same. We generate a random number between 0 and 1. If it's less than 0.25, we create a new direction and tell the user that they have changed direction. We detect for the left and right hand sides of the game board. We detect for the top and bottom sides of the game board, so that hasn't changed at all. We've got the try catch method, which takes the inspect X and inspect Y to check for whether there's a window there. Apologise, it's not for if there's a window there, it's if we've actually caught them. So what we do is we check for the proximity or the distance between ourselves and the Window Smasher. That uses the distance method, where we send those two values and calculate the distance using Pythagoras theorem. If it's less than 1.5, we now play a sound and say that we've caught them and return true. If it's less than 2.5, we've got a sneak, so they get an extra escape score, which is 10, and return false because we haven't caught them. Or if it's greater than 2.5, we've been nowhere near. There's our Pythagoras calculation, and then we've got our check window, and again that hasn't altered again at all. We modify perform modulus on X and Y position of the Window Smasher, and if both are 0, then we add 5 points and tell the user where they were. And then we've got our new method, which is play round. This is to play 1 round. It doesn't repeat. That'll come a little bit later on. So in play round, we've got 2 integers called look at x and look at y, and a boolean called smashed 1. Now smashed 1 basically means if a window has been smashed. So we initially make the initial move for the window smasher, and then we have a loop, and we keep doing that loop while smashed 1 is true. Now that is the first move, the second move, and then we check the position. If we check a window and we do the modulus of x and y given a remainder of 0, then that will return true. And if it's true, they'll move again and check again until that becomes false, in which case they get one final move. Then it's our turn. We type in a possible x location using user.inputInt and a possible y position using user.inputInt, and then we store those in look at x and look at y. Those are used as parameters in try catch, which is all the way up here. Inspect x position, inspect y position. We find the distance. We've either caught them, sneaked, or nowhere near. And that's 1 go, 1 round. So we'd have to continuously run that play round, and we do that in our main method. Now main is the new one. This will run the complete game of everything above it. The structure is slightly different. You may have seen this in books or online, but it basically starts as public static void main, and we set the winning target as 40. This will be completely new to you, because what we're actually doing here is creating an instance of a window smasher without right-clicking the class and putting the little red instance block at the bottom. So what we say is we have a new window smasher called WS, and we create that a new window smasher setting the target score for this game. So we're creating an instance of the game, and what we do is, while in this loop, while the current score of the window smasher is less than the winning score, which is in this case 40, and the window value of m caught for the window smasher is not true, i.e. while he's still roaming freely around the board and he's not reached his winning score yet, we will continuously play rounds until he's either been caught or he's won. If we escape this loop and he's not been caught, he's reached his winning score and he's gone, and then that's the command to exit the system or exit the program. So let's have a look at that as it's working. So again, I'm not going to go and create a new window smasher. I'm actually going to create a main where it will create a window smasher for me. Now, that's a bit different. So it's saying it's asking for a value. We can ignore that, and straight away it says this is move. Obviously not reached anywhere, so they're down the bottom. So let's say x is 3, y is 9. Okay, so straight away we've got a sneak, so 10 points to the smasher. Less than 25% chance has changed, so we still don't know what direction they're moving in. And the smasher has now bounced left, so he's moved from bottom to the left hand side. Change direction again, so we'll try and catch him this time. So we said left bottom, let's say they've moved up a little bit. So let's say 1, 7. And at this point I've caught them at 1, 8. Okay, so they've not reached the final score of 20 and I've managed to catch them at 1, 8. So quite a lot in that. It will probably be worth your while to actually get hold of this particular program and manually go through its functionality from start to finish. It's a big old program. A lot of it will prove useful if you in the event that you have to complete assignment 2, and a lot of functionality will help you. Well, not a lot. You won't need to use it all, but it will help you a lot. So it's a good idea to get hold of this particular program and pull apart its functionality to make sure that you actually understand it. So that's been quite an extensive presentation today. We've implemented the Window Smasher case study in stages. We've looked at some of the functionality. We haven't implemented all the new ideas. I've actually taken out some of the ideas to simplify it a little bit. So things like Smasher sounds and Javadoc templates I've left out for now because I wanted to concentrate on the functionality of the program. But one of the main things I wanted you to look at from this is how we can use a main method in order to create instances of objects without the need to actually right click an object and create an instance and inspect it in the normal way that we do it. We're not going to be doing that all the time, but certainly for assignment 2, where you're going to have quite a sort of similar program to this, you will be thinking about, or you need to be thinking about, how to implement that in a lot more detail, because you're going to create multiple objects and call multiple methods of those objects. So it's a bit of a pre-warning. We have got some other lectures to do in the meantime, but it gives you something to think about over the next few weeks. And certainly what I would be expecting you to do now is getting hold of this Window Smasher program. If you have to print it out, or if you want to inspect it on screen, you need to be able to pull apart how this thing actually works in order to gain a good understanding in readiness for assignment 2.